In this video, I'm going to go through how we can aggregate an order book to different levels of granularity using pandas in Python. So for an example of what I'm talking about here, we can look at this order book on Binance here, and we've currently got it set to the lowest level of granularity available. So the lowest increment in which you can place your buy or sell orders is 1 penny. And we're looking at every single price level on the book here. But the price of Bitcoin is moving much faster than that every second or so. We can see it's moving multiple dollars here. And so these orders are getting quickly placed and then filled and then taken away. And this can be very chaotic and hard to read, especially manually. And it also might not be suitable for certain algorithms. So we might want to aggregate this up to every dollar, let's say, or even every $10 or $100. And that way we can get a better overview of what's happening on the book and where areas of resistance may or may not be, where certain areas of demand might lie, etc., etc. And so how do we go about doing this in Python? We'll first need to head on over to the documentation here that comes with Binance. I'll leave a link to it in the description. And if you go over here to Orderbook, we can request an Orderbook snapshot here that gives us all the price levels for the bids and asks, which we can then later aggregate. I'm using a Orderbook snapshot here just because that's very easy to show. But the aggregation techniques I'm showing you will work just as well with any order book from any exchange, whether you're updating it live with a WebSocket or whether you're requesting snapshots like I'm here. So let's go dig into Python and we'll get started. So the first thing we'll need, as usual, is to import a few libraries here. So the main ones are going to be pandas, so we'll import pandas as PD. I'm assuming most of you are familiar with pandas. We'll also want the requests library. That's how we're going to request our market depth snapshot. And I'll also import math here, as well as the decimal module. So from decimal, import decimal. The decimal module is going to become important later on, as when we're dealing with currencies, as we do in order books, it's extremely important that we don't accumulate any floating point errors when dealing with these very exact sums. We wouldn't want the price levels to be slightly out by a very small number due to floating point errors. I'll give you an example of what that looks like later on and why I'm using decimal here, but for now, just roll with it. So next we need to do a little bit of configuration here. So we'll define a symbol that we're going to grab data for. I'm going to use Sol USDT here, mainly because it's much lower volume than something like BTC USDT, so we don't have to request quite as many price levels, and the price is also in a reasonable range. It's roughly $20 at the minute. If you're looking at an asset with lots of zeros after the decimal point, like if you were looking at, say, Sol BTC, it's very easy to misplace a zero and get yourself confused. So I'll use Sol as my example pair here, and then we need to go grab the API URL. So that should be available somewhere at the top of the Binance documentation. So if we have a scroll through here, we should find it. In this general info section, https api.binance.com. So let's grab that and set that to our URL here. So URL is equal to this. And then we'll need the specific endpoint to grab the order book here. So I'll go market data endpoints, order book. Then this is the end of the URL here. So I'll just paste that onto the end of the URL. If you have your own system for gathering your order book, whether that comes from a live feed or otherwise, that's perfectly fine. You can just replace the next few lines I'm going to do here with whatever system you have. We'll then set the interval here, so interval, and that's going to be a decimal, and it's going to be 0.1. So Sol USDT, if I go look at it here, so Sol USDT, the default aggregation level is 1 penny. I want it to be aggregated to 0.1 of a dollar here, so 10 cents. I'm selecting this manually here and just manually saying 0.1, but you could of course make this dependent on the pair that you pick. But for this example, it's worth just hard coding in here. And then we also want to set some parameters here. So params is going to be equal to symbol and symbol. So we want to set the symbol to Sol USDT. Otherwise, Binance doesn't know which pair to give us. And we'll also want to set a limit here. And that's going to be the amount of price levels that we receive at the lowest level of granularity. So for Sol USDT, that will be levels in increments of 1 penny. If you go to the REST API documentation over here, you can see the different parameters are defined here and their minimum and maximum values. Okay, that's great. We've got our example data here, and this is going to super easily allow us to extract an order book. So we can just do requests.get, we'll pass in our URL, our params here, and then we'll serialize it to JSON here, and then we'll print it out to see what it looks like. As you can see, it's just a bunch of bids, and then if we scroll down a little bit, we'll also get some asks. We asked for 100 price levels in either direction, and so Binance will try its best to deliver us that. You'll notice that everything is in strings here. So the first entry in this list here is the price level. So that's the $18.60 price level. And the second entry is the accumulated volume at that price level. They're both given to us as strings here, as you can see. And this ensures that there's no errors in terms of these values being slightly out. We have it as a string, and so it's going to be perfectly precise at 18.6 here, or 18.59. So I'm going to split this into two separate data frames here. The first one is going to contain all the bids, and then the second one is going to contain all of the asks, and then we're going to join them back together again. The reason why we have to do this is that you aggregate the bids and the asks differently. So if we go to the order book here, for the asks here, you're aggregating everything from the mid price up to this level, and then everything from above 19 to and including 20, and then everything above 20 to and including 21, etc., etc. Whereas it's the opposite on the bid side here. This level is everything from the mid price to and including 18. This is everything below 18 to and including 17, etc., etc. You'll see those differences a little bit more when we actually program in the math to do the aggregation later on. So let's build our two separate data frames here. Thankfully, Pandas makes this very, very easy for us. All we have to do is create a new data frame here. I'll call mine bid_levels, since that's what it represents ultimately. And all you have to do is pass in this list of lists here that we have, so this list of lists, into the data frame constructor here. So data frame, pass in the bids, and then we'll print it out to see what that looks like. So bid levels, let's print that out. So we could do with some column names here so that we know which one's which. So I'll set columns is equal to price and quantity. And run that again. And then if we print out the D types here, you'll see that these are still saved as strings. The pandas function we'll be using to bucket them later on doesn't accept strings, so at this point we'll have to convert to a float. Ultimately, it's okay to do that because we're not going to be doing any arithmetic with these. We're not going to be adding or subtracting or multiplying these values by any numbers. And so we're not going to accumulate any floating point errors, which could mess us up. Now what we need to do is we need to create a list of the boundaries here for the different price levels we want to aggregate to. So in this example, we're on the bid side here. So we'd want a price level at 18.6 here. If we were aggregating to the 10-cent level, we'd want one at 18.5, we'd want one at 17.6, so on and so forth. We need to create that list of bins that we're going to put our data into so that pandas can do that for us. We'll need the minimum and the maximum value here from this price data frame. So let's start with the minimum bid level here. So I'll create a variable, I'll call it min bid level. And essentially what I want here is the minimum value in this data frame rounded down to a multiple of our interval. So in this case, it just so happens that it is exactly 17.6, and therefore it's an interval of 10 cents. But if I were to run this again here, let's see what happens. I'll comment out this partially formed sentence here. I suspect our bid levels here would be markedly different. So you can see it's now 18.03. We want our minimum level here to be 18 flat. In order to achieve that, what I'm going to do here is I'm going to take the minimum value of bid levels price here. So we'll do min bid levels not price, and I'll divide that by the interval, and I'll print it out here so we can see what's going on. So min bid level. It'll complain here that this is unsupported between a float and a decimal. So we'll have to convert one of these into the other data type. You can convert this one to a decimal or this one to a float. I don't think it matters too much. So we'll try that. And we get 118.3. Now I did say earlier that we weren't going to do any arithmetic on these numbers because we were scared of floating point errors. The reason that's not a massive problem here is I'm now going to round that down using math.floor. So I'm rounding down to an integer anyway, so it doesn't matter that much in the grand scheme of things. If our bid level here is slightly too small, that's perfectly fine. We'll just have an extra level in our bid data frame, which we'll remove later on. So we should now get 180 here, and then we multiply that by our interval here. What that's going to do is get us that value that we wanted here, which was this value, the smallest value, rounded down to the nearest multiple of our interval. So if I run this again, we'll now get 18.0 as a decimal. So that's great. I now need to do the exact same thing for the maximum value. We need to know when to stop here. So I can do max bid value. Well, this time we want to round this up to the next value. That's a multiple of our interval. So instead of math.floor, it's math.ceil, which rounds up. And instead of min here, it's going to be max. And I'll print that value out here. So max bid level. We can see it's 19.1 here. Now, one thing we'll want to do here on the bid side here is we'll want to add an extra multiple of interval to the max bid level here. So I'm going to add 1 into here. And so we'll end up with a max value of 19.2 here. Or we will do if I can get my syntax correct. There we go, we've got 19.2 here. And in this example, that's unnecessary because 19.1 would be enough. If you think about all the dividers between the different price levels here, we'd have our buckets going from 19.0 to 19.1, and that would be enough. But if this data frame ended here, so say it ended on this value of 19 up here, and that was the highest value, because the bid aggregation includes the lowest value, so if I go to the order book again, this value at 17 here includes all of the orders placed on the 17.00 price level. And because of that, this needs to be included in the 19.0 to 19.1 bucket. Therefore, our maximum value needs to be 19.1, but if we just round this up to the nearest multiple, we'll just get 19.0, and we won't have that 19.0 to 19.1 bucket that we need. You can play around with that for yourself later on, and you'll see why we need this +1 in here to make sure that we've got enough price levels. Okay, so that's our maximum and minimum bid levels here. Now what we need to do is we need to construct a list out of these minimum and maximum bid levels at our regular intervals here. So I'll show you why we're using decimal here. You'll note this is again a decimal. If I were to just create some random list here, so say I was to create a list from 18.0 and I was going to add our interval, so 0.1 times x for x in range, let's say 40. If I were to run this and display it, what will happen most of the time is you'll get some sort of floating point problem. So if I run Python here and I run it in there, or if I try it with some more interesting numbers, maybe I'll try 8.5, 0.11, you can see if we mess about with the numbers a little bit, every now and then you'll get an answer that isn't quite right here. This is slightly bigger than 22.24. And like I said, if you mess around with these, if you do 0.15 for example, or 0.17, if you try a few different ones, you'll get a few of these floating point errors accumulating, especially if you do larger and larger numbers here. So if I get 400 values, you can see they're often not exact, which is a real problem for us. We want the bins to be exact because we're dealing with currency here. It's very important that we're exactly precise. And that's why I'm using decimal rather than floats, because, well, by default, these values here are float values. Whereas if we use decimal here, so I'll just clear this. I'll exit, clear, and then reopen it. And if I do from decimal, import decimal, and I do the same sort of thing here, but instead of this, I use a decimal. So decimal 18.0 exact plus decimal 0.1 exact. What I instead get is all of these decimals, which are exactly correct here. And no matter how much I crank this up, how many different decimals I add to each other, these are always going to be correct here, unless you're doing something truly ridiculous. And so I hope that explains why I'm being insistent on using the decimal module here. It's to make sure these bins are exact. They work for these values here, these particular values I've selected, but in general you're prone to some errors with floating point numbers, which is going to slightly mess up which values belong in which bins. So hopefully that's clear. Let's move on. And I'll create the bid level bounds here. So bid level bounds. These are going to be our boundaries between the different bins. And so we want to start at the min bid level. And we want to increment in values of interval. So interval times x for x in range. And what do we want that range to be? We basically just want it to be how many intervals are between this value and this value, which is easy enough to compute. You just do the max bid level here, minus the min bid level. We'll divide that all by the interval, and then convert that to an integer. So we want to make sure this is a whole number, otherwise Python will complain at us. And so if there's a difference of, let's say, 0.5 in here, we want there to be 5 intervals. Let's print out the bid level bounds here and see what that looks like. So we can see it only goes up to 19.1 there, so we'll want to add an extra iteration. If you know anything about the range function here, you'll know that it's not inclusive for the top value here. So if you ask for numbers from 0 to 10, it will actually only give you 0 to 9. So that should be good here. If I run this, we now have 18.0 to 19.2. And if I print out my bid levels data frame here, we can see that that's correct. With this list of bins here, we can correctly bin every single one of these values. We can sort them in a bin that has an interval of width 0.1 or 10 cents. Now the pandas function we're going to use here doesn't accept decimals, so we'll want to convert these back to floats. But that's again fine because we're not going to do any further arithmetic on them. We've already done the dangerous part that could introduce floating point errors. So converting to float won't do us any harm at this point. So I can run that. And now we can run the magical step that's going to actually bin all these different price levels for us. So I'll create a new column here in our bid levels, and I'll call it chunk, or we could call it bin. And this bin is going to be equal to pd.cut, which is the superstar pandas function we're going to use here. And it's going to take in the values which we want to bin and the bins themselves. So the values which we want to bin are the prices. So it's bid levels.prices. The bins is going to be bid level bound. It's going to be these values. There are a couple of other arguments that we need to think about here. The main one is going to be this argument called right here. And what this does is it decides whether these bins are going to be closed on the right hand side or closed on the left hand side. So basically, does this bin here between 18.0 and 18.1, does a value of 18.1 fit into this bin? Yes or no? Or does a value of 18.0 fit into this bin? Yes or no? It wouldn't make sense to have them closed on both sides here. So you couldn't say, yes, both the lower value and the upper value is included in this bin, because 18.1 would then be included in this bin and the next bin, and so it would get counted twice. So you just have to decide, do we want to include the right-hand values or the left-hand values? And that's what this value of right does here. So if right is true, we include the right-hand values, and if right is false, we include the left-hand values. And as I mentioned earlier, this is the bid level, and again, as I mentioned earlier, the bid level includes, for example, in this case, this value of 18.0 gets included in this level, whereas a value of 19 would not get included in this level. So the intervals are closed on the left-hand side, which means we have to set right equals to false here. There is also a precision variable here, so precision attribute. This is the precision with which Python stores the different bins. By default it's 3, which is enough I think for this case, but I'm just going to be paranoid and set it to 10 to make sure that we have enough accuracy here. Again, when we're dealing with financial data, we want to make sure this is accurate. So let's see what that looks like here if I print out the bid levels. It's now complaining that it has no attribute prices. I believe I called it price here, so let's set that. And there we go. You can see that each of these has now been assigned a certain bin. So this value goes in this bin, and at this point it might be a good idea to print out the data frame, make sure they're all in the correct bins. There's been no funny business with floating point numbers, but just looking at a few values here, they seem to be in the right bins, so that's good for now. And then we can do a very simple group by statement here to take the sum of all of the price levels that fall within this quantity here. So I can set the value of bid levels here to be bid levels.group by, let's group by the bin here. So we want to take all values that lie within each bin. So this is one bin, this is another bin. I'll take an aggregation on that. And all I want to do here is aggregate the quantity. So quantity is equal to quantity, and we apply sum to it. Let's see what that looks like. So we've now got the quantity for each one of these bins. And then this bin looks a bit weird here, so let's sort that out. We'll do a reset index here. That will promote the bin to a column. And then we can either change this column or create a new column. I'll create a new one. So bid levels, let's call it label. is going to be equal to bid levels.chunk.apply. So we basically want to grab this number from each of these intervals here. So let's apply. We'll write a quick lambda function here. So it takes x and grabs x.left. So we want to grab the left attribute here. And now if you run that again, data frame has no attribute chunk because I called this bin here. There we go. You can see we've now got the label. So that's what we display if we were writing some kind of UI like this. That would be the bin label here. And then at that point, we're pretty much done here in terms of aggregating our order book. We can aggregate this to any level that we like here. So if I set this to, let's say, 1 instead of 0.1, I'll run all these cells again. So I'll request more data. I'll run this. And I only requested something like 100 price levels here, so it doesn't have them all. It's not as comprehensive as this one, but if I request some more data here, you'll be able to see that in action. I request 1,000 price levels, or why not, let's request 5,000. You can see that's now filled out all these different bid levels, and we could compare that to the live one here. So that's looking good. One thing I'm going to do here is I'm going to set a new column inside bid levels, and I'm going to call it side, and that's going to be equal to bid here. And the reason I'm doing that is just so when we join the bid data frame here to the ask data frame for the purposes of displaying it, we can tell the difference between the bids and asks. So quantity here, and then side is going to be equal to side first. I'm just making sure that this new side column we have here gets carried through. If I run that, these are all now labeled bids. So what I'm going to do here is I'm just going to copy and paste this whole section and do the same thing except for asks. I'm sure there's a way to batch this up into some kind of function that can work for both bids and asks, but there are a couple of differences between how you aggregate them, and I'll point those out as we go. So I'll copy this down here into a new cell, and I'll just change all these references to bid to ask. That's essentially all you have to do at this point. So I've changed all of the labels there. There are two more adjustments that you'll want to make to account to the fact that these are ask levels and not bid levels. The first one is we want the intervals to be closed on the right-hand side now. So we want to set this to true, because on the order book, this value here, this value in 26, includes all values above 25 up to and including 26. So we want to include that right edge, and therefore we're going to set right equal to true for the ask levels. And consequently, because of that, instead of adding an extra price level above, we want to add an extra price level below. So I'll do a +1 in here. If this gets too confusing with just adding extra price levels above and below, just do a +1 on both of them, and then you can remove the price level that doesn't have any volume in it later on. But for the ask level, it's the lower side that we need to worry about. Because the intervals are closed on the right, we can have that problem if our lowest value is on the left side of the lower bound. Okay, let's run this here, make sure I did everything properly. The lowest bin here goes from 21 to 22. The current mid price is just over 20. So it might just be that we're out of sync here with the order book. Let me also print out ask levels here, just to see what it looks like. We can see that we're missing this bin here for the lowest price levels here. So something's gone wrong over here. Yeah, it's because we added the +1 here. We should have minus the +1. So we're looking to extend the range here. We want to make sure we include the price level below the current one, not shorten the range by increasing this minimum ask level. Hopefully that makes sense. We can see that these are now properly binned, and I can run this. Now the bins on the ask side derive their label from the right-hand side of the bin here, so I'll change that briefly. And there we go. What I can do now is I can say the order book is equal to bd.concat We'll put the ask levels and the bid levels in there and see what that looks like. So order book. That looks good to me here. If I print out the full order book here, we should be able to see the points where the bid and ask cross. So I'll do order book dot to underscore string here. Got our ask side here, and then the bids down here. You can see that these are all in the wrong order, so let's sort them out. So we'll do dot sort values. We'll sort by label, and we want to sort descending, so we want the asks to be above the bids. So I think it's ascending equals false is how you set that. Run this again. Now we have our nice, lovely aggregated order book here. Now you can see there's these levels here, which are a bit confusing. These are the extra price levels that we added in as a result of our widening here. So you can see this one, and there's this one here. These are getting put in there. So just to stop that from happening, we can filter out those values by doing order book is equal to order book. Order book.quantity is greater than 0. So we only want to include price levels that have a value greater than 0. There we go. This looks a lot neater now. And the bid and ask cross nicely there. So we should check our aggregated order book here against the one provided by our exchange here, in this case Binance, to make sure that we're doing things properly. And to do that, basically just pick a pair that doesn't trade that often. So I have found one before in this video, and I'm going to use a pair called b./dot. Now this pair does not trade very often. It gets maybe one trade every 5 minutes. Therefore the order book is very stable. And so if I ask for data from b.dot here, let's try and organize my windows. And I get my order book information here. We'll use b.dot. We'll aggregate to, let's say, a 0.01 level. So 0.01 level. We'll run the whole script. And if we go down to the cross between the bid and the asks here, we can see this is 4553.983. This is that one. 9853.374. 0.806. Okay, those are good. The bids, 913,590,947. This one is slightly different here, but I suspect that's just because someone placed an order. If I run the whole thing again, let's check the 0.73 level. 626. Yep, that's exactly the same as the exchange. So that's how you can quickly check that your order book is actually the same as the exchange. Just pick a really liquid pair and compare your order book to the one on the exchange. One final thing that I'm going to show here is how we can convert the units that we're using here so that we do all of our calculations using integers, and therefore we don't have this anxiety around using floating point numbers, which can definitely be a little scary. So I'm going to convert the prices here so that instead of being 4 decimal places, it's going to represent a whole number here. To do that, we need to get a conversion factor. So I'll just call it factor here. That's going to be equal to data.bids. Let's say 0. See what that looks like. Dict attribute has no object bids. Yes, because it's not a data frame. It's actually just a dictionary. Let's grab the 0th element and we'll print it out so we can see what it looks like. And then let's grab the 0th element of that again. And so what we get is this string here. And what I'm going to do is I want to find out the precision of this number. So in this case, it's 1, 2, 3, 4, 5, 6, 7, 8 decimal places. So to get that, we can do something like this. So precision is equal to factor.split on the decimal point here -1, so we'll get the last element, and then we'll get the length. And I'll print out precision here. Precision. So we can see that prints 8. We have 8 decimal places of precision, and therefore our factor here is actually going to be equal to 10 to the power precision. So we want to multiply this by 10 to the power 8, which will ensure that this number is an integer rather than a decimal here. So let's go through and convert all of this data here. So I'll make a new cell, and I'll set this value called bids. So this is going to be our new bids with these converted to integer values. So bids is going to be equal to data bids. Let's just set it as that for now and print it out. And then what we want to do is we want to go through here, convert this string to a decimal, multiply it by our factor, and then convert it to an integer. So we can do that with a quick list comprehension here. Let's say something like this. So it's going to be a list of lists, and the first element is going to be the 0th element of this turned into a decimal, multiplied by our factor, and then converted to an integer. Then the quantity we just want to leave alone here. So that's going to be x1 for x in bits. Let's see what that looks like. Let's run this again. I think I didn't set the factor there. There we go. So now these are all integers, which makes life a little bit easier for us. We can do the same thing for the asks here. So I'll print that down here. Asks is going to be data asks. And we want to make sure that we're doing this conversion to integers here. And we'll print that one out, make sure it's all accurate. Looks good to me here. We can do the same thing for the quantity here to keep everything as integers. So you'll do the exact same thing we did for this here. So we'll keep a factor for the price and the precision for the price. And we'll keep them separate here. So precision price. Just in case the quantity here is given at a different level of precision than the price. I'm not sure if that would happen, but it's better to be prepared. And then I'll create a new cell here for the quantity. And this will grab the first one. Okay, so we've got those, and then we can convert this over. Factor price, and this is factor quant. And now they're both integers, which means we can set this d type to int. We'll also want to set our interval here to be the interval multiplied by the price factor here. So I'll do that down here. So interval is equal to interval multiplied by factor price. We'll divide everything again by the factor at the end so we get accurate results. That means we don't have to convert to a float here because everything's in integer. We don't need to do any floats here because everything's an integer. We'll make sure, in fact, that this is an integer by converting it here because interval is a decimal, so we need to make sure that it's actually converted to an integer. And at this point, we should be good here if I run this. Looks like it's unhappy here. If I print out the bid levels, what does that look like? We can see it's taking data here from that rather than using our bids. That should fix things for us. For some reason the bins are too large here. I suspect what might have happened is we've ran this twice here. So I'll set the interval inside here. So rather than setting it up here, I will set it down here. because if you run this twice, it's going to multiply it by the factor price twice. Let's run this again. Yes, now we've got properly sized bins here. There are some areas with no bids and asks, but you'd probably expect that on a pair as illiquid as the one I'm looking at here. And so now it should just be a matter of converting this to asks. Again, we get rid of all this float nonsense. We're not using floats anymore. Run this. Make sure that is interpreted as an int. There we go. And then we should be able to print out the order book here. Great. And then all you need to do to convert this into something that you can read is just divide the label and the quantity by the interval, or the factor for the price and quantity respectively. So just do order book dot quantity divide equals factor quant, and order book dot label divide equals factor price, and then print out order book. And there we go. We're back to 4 levels of decimal places here, and we can be confident that there's no shenanigans going on with floating point numbers because we're just using integers here. It's up to you whether you want to use this method. It's a considerable amount more processing in here in terms of over here where we converted the bids and the asks. This is going to be somewhat intensive. You're converting to and from decimals. There might be a quicker way to do it, but this one does work. And so I'll leave it up to you which method you choose, whether you go with this approach here of converting everything into ints so that it buckets nicely, or going with floats, which should work in theory, but I never trust floats. Let's do one final check here to make sure that this order book is correct. I'll just run the whole Jupyter script. I'll pull up Binance here, and we should be able to check our order book. I think I have to do a print order book.toString. And helpfully it's not writing everything out here. So let's just grab quantity, side, and label. So something's gone horribly wrong here. I suspect this is Jupyter's problem. It might have not run these in the correct order. Let's just do it manually here. There we go. So yes, when I did the run all there, it looked like some of them got run slightly out of order, which produced this problem. If I go down here to the bid and the ask, it looks like I need to sort everything. Add that in here quickly. Dot sort values, label ascending equals false. I'll copy and just run this in its own box because otherwise we'll divide everything again. There we go. So let's look for the bid and ask. Should be some down here. So these levels look to be completely inaccurate here. So let's go and figure out what's wrong. Yeah, it looks like up here I forgot to change this to a 1. That's why we were having problems with our order book there. So if I run the whole thing again, our order book is looking considerably healthier here. And if I go over here, compare that against the one that we have running, 825.607, 25.340. Yep, that is running correctly here. And so that is 2 ways actually of aggregating order books in Python. We chose one method using floats, which is quicker, requires less computation, but is potentially risky because it involves floats, and floats are very scary. And I also showed you another method where we multiplied the whole thing to make it into integers and we use decimal to make sure that we don't lose any accuracy. And we got the same result in the end, which is our aggregated order book, which we can include in any of our algo trading projects, whether you need it for visualization purposes or to feed into your algo. And the great thing about this is that we're not limited to the levels of granularity that the exchange provides. If we wanted levels of 0.2 rather than 0.1, we can do that, no problem. So I hope you found this video helpful, and I'll see you in the next one.